Hello, viewers and my dear students. Welcome to Projection of Planes demo. Here we'll take a demo on a simple triangular lamina. What we have done already under Projection of Planes different sessions. It is only to make you know how to use solid edge to do the problems. These things have been covered in your classes and all that, I'm sure. But this will be a sort of revision for you. Okay. Okay, now you see here. Now we'll say one simple problem we'll try to solve. A triangular lamina of size 25 has an edge on HP inclined at 60 degrees to AP. The surface of the lamina is inclined at 60 degrees to HP and all that. Okay, this is a simple problem. What you have done in detail under different sessions under plane surfaces. That is projection of plane surfaces. Okay, now we'll start with this. How to do using solid edge. Okay, now you see here. I'll start with one XY line. Okay, immediately before you forget, this is times New Roman. Okay, you can take 5 also. 4 or 5 you take. XY, VP, HP and all that you take. Okay, then you see here. X you take here. Here, this border if you want you can have. Otherwise you change the border. Don't have the border. XY, even VP also. Sometimes some people have border. If you don't want, you click on this. The border will go off. This is VP. Okay, now it's a triangular lamina of sides 25. You see here, it's a triangular lamina of sides 25. See here, I was telling you when we are doing this size 25, no? 25 you draw one vertical line. Once you draw this will be 25 plus 30. Okay, this will be 25 plus 30, or you can expect alignment indicator also 25 plus 30. Otherwise also if you start from here, you take 25 minus 30 you take. Okay, anything is okay. 20 if you draw this line 25 plus 30, if you take this 25 minus 30 you take. In that way you are able to complete this problem, complete the triangle. Okay, now as you know here 25, this is the top of the triangular lamina. You can dot connect. Okay, now before you forget this, you can name the corners also. Okay, this is A, B and C, you have it. Okay, okay, this is A corner, this is B corner, this is C corner, and you can dimension this. This is a side of 25. Okay, when you look from here, when you are looking from here perpendicular to VP to get the front view, no? Front view, this is the top view you are drawn. This distance can be anything because the front views or top views don't change irrespective of this distance. Okay, and now what I suggest is you leave some distance, some 30 mm, 35 mm. In that way, you draw the top view. Okay, once you have drawn this, okay, when you're looking from here, this is completely lying on HP. Okay, right now. That means B is seen, A is not seen. That is why you see here, you take like this. Okay, first you take only till this only. Okay, take only till this. Then you join from here to here. Okay, and immediately before forgetting this portion, no, you increase it to zero point 0.5 or zero point 0.7. Okay, zero point 0.5 would be convenient. Okay, once you have drawn this, B dash bracket A dash and C dash. C dash you make it, because when you're looking from here, B dash can be seen, A dash cannot be seen. In that way, I have done this. This is B dash bracket A dash and this is C dash. Okay, once you do this, you see here, I have told you there is one imaginary line here. If you observe, this is the median, actually median. Now this is parallel to XY line, no? This is parallel to XY line. In that way, whatever you are seeing here is the median length only. Okay. Now it is right now it is completely lying on HP. Now if you pull this, that means if you lift this corner, it will be edge on HP. If you lift this point up, it will be corner on HP. That is why I've told you in different sessions under projection of plane surfaces, once you draw triangular lamina with one of the edges perpendicular to XY line, edge on HP or corner on HP can be made to rest on XY line by one single position. Now in this particular problem, a square triangular lamina has an edge on HP. That's why now edge on HP means B dash A dash should be on XY line. If corner is on XY line means corner is on HP means you should make C dash on XY line. Okay, that is why what you do now, this you be careful here. Okay. Now you see here, this is the move command. This is the move command. Now here, move copy is also there. Now I want copy also. That's why I'll darken this. That is, I'll highlight this also. Move and this copy also you do. Select this now. And with reference to this on the end point, I'll move it somewhere here. Okay. And I'll put escape. I'll put this escape. Okay. Now once you do this, I'll rotate this. I'll rotate this. And if you see here, how much it has to be rotated is, the surface of the lamina is inclined at 60 degrees to HP. Okay. That is why what I'll do now, this rotate, I'll click. Okay. Rotate, I'll click. I don't want this copy now. Okay. Only rotation is needed. Okay. I'll highlight on this. I'll take this end point because it should be on HP. This is another point about which it has to be moved. You take it this way. How much it has to be moved is, I think 60 degree. In the rotation angle, no, you put 60 degree. Okay. Once you put 60 degree, it is over. That means this triangular lamina has an edge on HP. Surface is inclined at 60 degrees to HP. Okay. In that way, you see here, if you measure this, it is 60 degrees to HP. Okay. Now, once you do this 60 degrees to HP, and you know very well, once you do this, first stage, this is called first stage front view, this is second stage front view. First stage front view and second stage front view are same, because in this position, it is edge on HP with surface inclined at 60 degrees to HP. Whether it is in this position and this position, this imaginary median is still parallel to VP. Okay, even if you tilt it, it is like moving this lamina in such a way that median is inclined at 60 degrees to HP with edge on HP. That's why this front view and this front view are one and the same. That is why take the same front view, move the, as I said, this move and copy, okay, and then rotate to 60 degrees. Then what you do is, from here, no, take the projectors down. Okay. Now, if you do all this, as you are aware, this extra things and all that, you can trim it off. Okay. Extra things and all that, you can trim it off. Okay. Now, you know very well, you practice this habit because as you have already experienced, this will help you in projection of that is solids and all that. This point is there. This point is also there. There is one point here. Okay. As you know here, this is point A, this is point B, this is point C. Now what I'll do, from here to here I'll join, from here to here I'll join, from here to here I'll join. Okay. Now if you do this way, okay. Now if you do this way, right now it is edge on HP with surface inclined at 60 degrees to HP. Okay. And if you bring the lettering, this is A, B, C. Okay, you take this. This is A. This, as you know, it is B. This, as you know, it is C. Correct? No? This has been done. This you know already how it has been done and all that. Now it is edge on HP with surface inclined at 60 degrees to HP. For this, when you're looking from the top, okay, this is how it is seen. Since, as you know, CB and CA are now it is inclined, the CA and CB are not in true length. But here they are in true length because it is completely lying on HP. Now I have tilted in such a way that edge is on HP, surface is inclined at 60 degrees to HP. When surface is inclined at 60 degrees to HP, when you are looking from the top, how it appears, I have written here. Did you follow? Okay, please follow. This is by looking at front view, top view, you must master this art. The master this art in the sense, see here, I'll start from XY, VP, HP. Correctly position it. Okay. Okay, then you draw a triangle of 25. This is AB. This is BC is what? 25 plus 30. This is 25 minus 30. Or take the alignment indicator and that way you complete. Then when you are looking from the front, it is B dash, bracket A dash and C dash. Okay. Then see here, this is the median length. Now, since edge is on HP, I have pulled this corner up. Okay. If corner is on HP, I would have pulled this corner up. Okay. So that C dash is on XY line. Now, since edge is on HP, I have made B dash, A dash on XY line such that the surface or median, this median, imaginary median, inclined at 60 degrees to HP. In that way, when you look from the top, okay, you should know that only AB, since it is on HP, only AB will be in true length and AC and BC will be in apparent lengths. When you look from the top, this appears smaller. This triangular lamina appears smaller. Here, it is actually the true length. That is why this entire thing was seen in its true length here. But here, since it is 60 degrees to HP, only AB, since it is AB is on HP, AB will be in true length and BC and AC would have lost true length because they are inclined. Now, when you're looking from the top, this looks smaller. Okay. Now, anyway, this will continue in session 2 of projection of plane surfaces demo, that is triangular lamina. This will continue in session 2. Thank you very much for watching. Please watch the session 2.